We're going to look at percent increase and decrease application problems. To find the percent increase or decrease, we find the change in amounts divided by the original amount and then multiply by 100. To find the change in the amounts, we always do the big number minus the small number. Then we divide by the original amount, which gives us our answer in decimal form. And we have to multiply by that 100 to turn it into a percent. If we look at this first example, it says the doctor increases my meds from 500 milligrams to 600 milligrams. What is the percent increase? So I would do 600 minus 500 and then need to divide the original amount. I originally was getting 500 milligrams of medication, so I would divide by 500. And I know I need to multiply that by 100 to get this into percent form. When I do my subtraction, I'll end up with 100 over 500. When I do that division, it gives me 0.2 or 2/10 times 100. And when I multiply by 100, I know that's the same as bumping my decimal point over 2 spaces. So that gives me a 20% increase. I know it's an increase because the meds are going from 500 milligrams to 600 milligrams. They're going up. If I look at the next example, it says the doctor decreases my meds from 20 milligrams to 15 milligrams. What is the percent decrease? So I'll follow the same process. I need to find the change, so I do that larger number, 20, minus that smaller number, 15, and I need to divide by the original number. They say that my meds were originally 20 milligrams, and then they decrease. So that 20 is the original, and I multiply by 100. When I do the subtraction, I end up with 5 over 20 times 100. Then I need to do the division, which gives me 0.25 times 100, which gives me a 25% decrease. If I look at another example, it says the nurse was putting medication into a syringe, and instead of putting in 1.2 milliliters, there was 1.3 milliliters put into the syringe. What is the percent increase? So for percent increase, I do the larger number minus the smaller number divided by the original. In this case, the original is what we should be putting in the syringe. So we should have been putting in 1.2 milliliters, and I multiply by 100. When I do the subtraction, I end up with 1/10 or 0.1. Then I need to do that division, which gives me 0.083 repeating. When I multiply by 100, I know I bumped that decimal point over 2 spaces to the right. So that gives me 8.3 repeating percent increase. Now, most of the time they ask us to round, and for percents, we normally have to round to the nearest 10th of a percent. So if you think about that 0.3 repeating, it means we have 3s, and they just keep going. So I'm going to take this 3 in the hundredths place. It tells me to leave that 3 in the tenths place alone. So if I round, I would just say 8.3% increase. If we look at this last example, it says the doctor changed the prescription for the patient from taking 15 milligrams every 4 hours to taking 20 milligrams every 6 hours. What is the percent of change? Is it an increase or decrease? And we're going to round our answer to the nearest 10th. So notice here, they tell us that we're getting 15 milligrams every 4 hours and that we're getting 20 milligrams every 6 hours. This medication is given at different times. So we need to find how much we're going to be getting in some common time period. So I'm going to look at how much we're getting per day. If we look at the original, we're getting 15 milligrams every 4 hours. If we're getting it every 4 hours, well, there's 24 hours in one day. If we divide by 4 hours, that tells us that we're getting this medication 6 times per day. So I'm going to take the 15 milligrams, multiply it by 6, and find that originally this patient is getting 90 milligrams of medication per day. If we look at the change, instead we're getting the medication every 6 hours. So if I do the 24 hours divided by 6 hours, I find that this patient is getting the medication 4 times per day. So I'll take the 20 milligrams and multiply by 4 to find that the patient is getting 80 milligrams per day with the adjustment. So because it's going down, that tells me that it's a decrease. Now I need to find the percent of change, or that percent decrease. So I'm going to do the larger number, 90, minus the smaller number, 80, divided by that original dosage amount, that 80, times 100. When I do the subtraction, that gives me 10 over 90 times 100, which gives me 0.1 repeating times 100, which gives me 11.1 repeating percent. Notice they told me to round to the nearest tenth, so that tenth is going to stay the same because the 1 in the hundredths place tells me to leave it alone. So I'll say that it's about 11.1% decrease.